My name is Joseph Wunderlich. I'm a professor of engineering, architecture, and computer science. This is a lecture on technology and humanity. First time I did this was in 2018, and revised it 2020, at the beginning of the COVID pandemic, and then 2021. I have a background in both engineering and architecture and computer science, and industry experience as well. I was born in 1961, spent the first half of my life mostly in architecture and buildings, and then into high tech, including robotics and machine intelligence. This lecture is color-coded with my opinions of what's good and bad, and the bad is in the context of old school qualities lost. We'll start off with robotics and then do machine intelligence, although most sophisticated robots have some degree of intelligent control. This is a project I worked on in 1993 at AI DuPont Children's Hospital for a couple years. While I was working on my PhD, I was an assistant researcher on a large project, NIH grant project, to make robotic arms for children with disabilities, quadriplegic children. Another application is for maneuverability for the disabled and assisted walking. A lot of the complications in implementing this kind of thing have been overcome recently with a connection between the electrochemical central nervous system of the human body with the typical electrical and mechanical systems for controlling prosthetics. This is in 2014, a direct implant into the brain controlling a robotic arm. Most recently, everybody's heard of this, most likely, of Elon Musk's Neuralink. He's most famous for SpaceX and Tesla, also somewhat for the Boring Company. And Neuralink is the latest thing that he's working on. This is a direct implant, hopefully to help with healing some of the disabilities, and then maybe with a little more work, transferring some artificial intelligence directly to the brain and back, with hopefully some very significant testing in the physiological and psychological effects of doing such a thing. So old school qualities lost none. It's curing people of serious disabilities, and as long as neural implants proven safe, both physiologically and psychologically. Robotics assisting in rehab for injuries. I do have a little of a concern about this based on experience, where I had a full Achilles tendon rupture, and I got a sports medicine surgeon to do the surgery, and I was back up on my feet in 6 weeks and went and taught a PhD course in robotics in Italy on crutches, but nevertheless I got there, and then the boot came off soon after while I was in Italy. Typically it would have taken 6 months, the old-fashioned way, where you wear a cast, a full leg cast. I know people have done this 20, 30 years ago, and then you don't recover full strength either that way. The new conventional wisdom is you heal under load, so you put a boot on and then you start loading the joint as it's healing. It can be a little more risky re-injuring, but you get a better chance of full strength returned this way. Medical imaging, so x-rays, minor radiation, CT scans equal to about 100 chest x-rays, still not a whole lot compared to the background radiation you typically receive, although if you do get quite a few of them for some reason, you might want to switch to magnetic resonance imaging, MRIs. And the old school qualities lost, I'm saying none here, because the benefits far outweigh the cost, in my opinion. Robotics for repetitive tasks and factory automation. This is my PhD research. I also did some consulting in robotics, visiting factories, and then creating a simulation to design robotic arms for going into enclosures and doing different tasks, tack welding, grinding, spray painting. This is an example resulting robotic design for 4 degrees of freedom from an original 5 degree of freedom robot that was then permuted, and this design was generated. Set up a simulation with some primitives and some rules for rappelling off of the walls. This is a show of a simulation run with a number of permuted designs, each of them tested to get into this enclosure and reach a goal far within. All the black circles are where there is rappelling within the rappelling fields. So the idea is to find a geometrically feasible set of designs and then look at some performance metrics. And so a number of performance metrics were assessed, including the minimal degrees of freedom, where, as I showed in the previous slide, reducing one of the joints, not needing one of the joints, speed, dexterity, minimal energy consumption, and this new term, minimal consumption of available redundancy, which I derived. Old school qualities lost? Well, perhaps yes, with the artisans disappearing. And here's some video of glass blowing in Italy that I took on one of my trips to Italy. Cleanup of human or nature's mess. Robots don't get sick from contamination. So 3 Mile Island, robots were used, Chernobyl, Fukushima. In 2014, the U.S. military using robots for killing Ebola. Can disinfect in minutes using ultraviolet technology. 2020 and 21, fighting COVID and using similar technology. This is from a green architectural engineering lecture where you can put these UV lights within the HVAC system, although it's a little tricky to make it work because you got to slow down the airflow enough to have enough time to kill the COVID, which is counter to the air exchanges recommended, so many air exchanges per hour, which is now higher for COVID, and so you're increasing the velocity, so it's a little bit contradictory there, trying to get the air to flow faster and keep it in there long enough to kill it with the ultraviolet. Some Google Scholar citations you can look at. Also comparing COVID to other contaminants, asbestos and mold, fire, smoke. A little more on this, you can look in COVID. In this lecture, I have these sources in Green Architectural Engineering, New England Journal of Medicine, showing that aerosol form, early on showing aerosol form, before everybody was saying in the news. The scientists working on this could see this clearly. ASHRAE, American Society of Heating, Refrigerating, and Air Conditioning Engineers, the standard for most of the world for HVAC, and a letter from the president of that to the World Health Organization stating concerns and the fact that fresh air is needed. One more thing on cleanup here. This is a novelty robot in Japan for shoveling snow, and then it leaves little cubes of snow behind. You can see just to the right of it there. Old school qualities lost. Personal attention less likely, I put. So, and of course there's benefits, but you need to worry about relying on automation a little too much, especially if you have people afraid of getting near a pandemic, a plague, healthcare workers dying, higher percentage in the beginning of this. And also for things like snow plows, having that automated can have problems, as you see in the bottom right-hand corner. Robots for exploration. We'll start with Perseverance, 2021, NASA Mars rover and helicopter. And you could click on this link here and look at all the parts of the robot and detailed descriptions of how it works. I'll go a little bit backwards in time here. 2014 Mars Science Lab, Curiosity. Similar tasks, no helicopter, also for science exploration. Curiosity. Curiosity. This is Boston Dynamics. Little controversial sometimes what they make. Exploration. There's a whole series of robots developed at E-Town under my supervision. My first decade here from 1999 to about 2011, 12. We have new robots now, but not for international competition. 2020s now, eBot 9, Delivery Bot. It delivers food to the dorms. Students use an app. It's just beginning development, has some minor successes, and a lot more work to do. Old school qualities lost. Well, it's safer than sending humans to distant worlds, but human-to-human first contact and general diplomacy could diminish in other applications. You send a robot to meet people for the first time. Now, search and rescue. So on the battlefield, this is an extraction robot. And a video you can watch about that. Going back 20 years ago, 21 years ago in 2000, before 9/11, students in simulation class had to compare their programs of simulation and real-time robots both, and they needed to match each other in performance equally with a search and rescue team. Then immediately after that, in 2002, a student went on to do environmental mapping and published a paper with me that he presented in Japan. Robots are great for extraction of people in natural man-made disasters where EMTs are not available or just can't get there. This is an earthquake that happened in 1989, right after I moved. I had just started switching into high tech at the time, and but had been working in a consulting firm, including structural engineering, and would commute over this bridge. This is the Bay Bridge over the San Francisco Bay between San Francisco and Oakland. Robots are no substitute for EMT skills at the scene. So if you can't get an EMT in there, or you don't have enough EMTs, or if it's a battlefield, certainly you want to send a robot in if get the EMT killed. But there is no substitute for having an EMT on the scene if you can do that. And I know that from experience. So, summing up old school qualities here for search and rescue, robots great for battlefield extraction of wounded soldiers, also great for extraction of people and disasters, but no substitute for EMTs if you can get them there. Tedious task, delivery robots. Things flying through the air traffic, noise. Old school qualities, maybe home delivery, the person actually bringing something might be delivering it, or the accountability. I see now during this coronavirus, when this is being recorded, 2020, my delivery people are taking pictures of the delivery all the time. I imagine people are grabbing boxes or just leaving boxes someplace and running away, where you used to get a signature. More tedious task is customer service. This is a kind of a fail. If you watch this, this is a demonstration of you pick a shoe and it delivers it to you and it actually drops it here. What about a laborer? Well, I doubt you would build a robot this expensive just for labor tasks. And then you decide if you need this kind of sophistication. This is a Boston Dynamics, DARPA-funded robot. Old school qualities lost, human interaction disappearing. Probably nobody watching this, or many younger people, wouldn't remember tailors, or perhaps in shoe stores there's still people giving you personal service. But there's something to be said that they still have this. I bought a couple of suits several years ago, not too long ago, where I had personal service. But a robot sizing, fitting, giving you a personal opinion, how you look. I think not. Customer service. This is getting more and more sophisticated lately, and so you could certainly do this a little bit for not intimate conversation. There's your robot. But if you ever had serious problems trying to switch flights, or your flights canceled, or tight connections, or I would much prefer a human as helping me, empathizing in a real way, and then helping solve the problem. So sincerity, sincere hospitality, genuine empathy could disappear. That's my opinion there. I don't see, the robot can mimic it, but I'm a long way from trusting the robot to really relate to me. Companions. Now, this is another thing, because we can do this even with a stuffed animal. So let's see. Watch videos. This one's a little scary. Asmo, perhaps the most sophisticated. No, well, you decide. Watch some videos. Look at some new things for companions. There's someone now that I didn't insert in here, but there's one that has genuine emotional facial expressions and is mobile. That used to be two separate robots. So you decide if you want that. These things can be scary. The first Asimo model was 300 pounds and over 6 feet tall, and it scared people. They didn't want to have anything to do with it. The new one's very submissive, moves slow, it's short and small. And so this uncanny valley, we get scared at things. We get frightened by things that scared of things. We are scared of things. We get frightened by things that almost look human, but are not. Old school qualities lost. Less human relationships. We start relying on these machines. We see it during the coronavirus here. Luckily, I have my wife and children with me here. There's lots of people all alone. And we drove around, my daughter and I, just yesterday, and we noticed that people are getting a little tribal. They have signs saying, don't come in here to visit. In retirement communities, understandably, but other places too. People are getting a little antisocial. Major trends in computing, ubiquitous computing, put them everywhere. You want your computer to be a nanny for your baby? I don't think so. Hopefully not. Now, learning and education, and during COVID, we're forced into using screens all the time for everything. However, in the early 2000s, staring at screens proven to be detrimental both psychologically and physiologically to your health, and that we really don't multitask as well as we believe. There is, however, somewhat of a silver lining to us all having to work remotely. We find new ways of adapting and connecting using technology. Here's a particular example of some excellent student work done entirely remotely, and the presentation of that. CPU design, pretty sophisticated, especially considering it was only worth a couple labs in one course. This is a virtual graduation for students, and a thing I put together for the students that I work most closely with. So some success there. You see the laboratory slowly ramping up, letting people back in, and taking all the precautions needed to get people working in face-to-face, hands-on work, which is critical in my opinion to at least the kind of education that I deliver in many of my courses. Some of them lend themselves to completely online very nicely, but others do not when you're building things. So old school quality is lost with learning, with just using the technology. Face-to-face with people is diminishing, but we may learn to be more adaptive. Drones. Rules of engagement. It used to be if you're in the battlefield and people are killing each other, that you at least spare some people on both sides no matter what. Perhaps some of that honor has been lost over the years. A robot doesn't have this ability. GPS navigation, relying on your GPS to tell you where to go. I don't like this. I mean, I use it now. I finally surrendered to it a little bit because I can't buy physical maps anymore, unfortunately. I like an overhead view and memorize where I'm going, and then I don't get lost anywhere. I mean, or unless I do it on purpose. Sometimes I like to get lost on purpose, so I don't look at a map just for the sake of immersing in some new world. Christopher Columbus's map, really no idea where he was going. He thought he was going to India, just sailed off. I mean, he had some idea, but you know, people were debating he'd fall off the edge of the earth, and he didn't know he'd run into America and call everybody Indians because he's thinking he's looking for India. Transportation. So you know, this driverless cars. My opinion on that is, you can see there's been a couple deaths. I certainly don't trust the trucks doing that with all the mass of them moving unless they have separate lanes. I'm a proponent of trains. So we see, you know, people get killed by these things. And you could argue, well, more or less people than when humans driving. These are debatable. You could see, you know, IEEE Spectrum. It's most, in my opinion, the most people's opinion, the most respected organization for technology. So, you know, this philosophical arguments here: should a self-driving car kill 2 jaywalkers or 1 law-abiding citizen? Right. So, if we were doing this in the class, we'd have much more discussion. This is a rapid overview. So you could see these hypothetical situations where the artificial intelligence is deciding life or death things. You know, are your valued pets more valuable than a car full of criminals that you don't know? Well, that's your opinion, right? You know, would you kill your own pet or let 5 criminals die? You know, not hardened criminals necessarily. Flying Ubers. I've talked to pilots about this, and I've yet to find a serious commercial pilot that thinks this is a good idea. Of course, there's other private pilots and other people think it might be. It's a level of risk and an understanding of the limits of technology. So, you know, human drivers' alertness and discretion lost with flying Ubers. Yeah. So, advanced robotics. This is certainly need more classroom time for this, but human mind is to the human appendage as machine learning is to robotics. So, when you put it all together, you're essentially creating something like a human if you've got a robot with intelligence walking around. This is topics, and you can drill down on other things. These I've designed and made 1 neural network chip, designed 2 neural network chips, patent disclosure on the first one 30-something years ago. And this is the stuff of other publications I have and in courses I teach. This is a paper that's often I ask people to read, and this certainly takes quite a bit of discussion in class and opinions. I love to hear the different opinions. This is an accumulation of survey data I've taken from students over the past 20 years, colleagues, other professionals in the field, professional psychologists, cyberneticists, machine intelligence people, deep learning people, and so it's a matter of opinions, but based in scientific reasoning in most cases. And so you can see all the mental abilities here. I'm not going to go through all of it. Definitely want to stare at this a little bit. Have publications go accompany all this. So we just skim through a bunch of them real quickly and group them together. Some virtual worlds. I've ran Minecraft servers, ran public and private servers from my home and hosted in New York City and Toronto, Canada, and had students, not just young children, older people too, and classes of students build things, architecture and digital design. You can take a look on my YouTube channel and see these things going on, these group builds and the interactions. So now I'm just keying on a couple of things here. Number 4, undetected bias, and this is in the AI. So I show an artificial intelligence program I write in expert system in 1991, and you can see the rules that I incorporate there and the reasoning and how that works mathematically, and my personal rules and how I assess confidence in those rules. And then you can trace the rules, how they fire based on the input of the user. And then you see where these decisions are being made, essentially. And I make a change, and I see what happens. And then I admit to unintentional gender bias here, picking a male toy for a boy and not letting a little girl have that as a choice. And then I had a little girl, 13 years after, 11 years after I wrote that program, and she wants to do boy things too. Good for her. And so she does. This is an introductory tutorial to machine intelligence, including both symbolic AI and neural networks. So in class time, this entire lecture you listen to now would be several lectures with subparts. And then this is another subpart here, which should reinforce anything you already know or have just learned about the difference between symbolic AI and neural networks. Now, this disinformation, while this is, since I originally wrote this, did this study almost 20 years ago, started it, and then things have happened. Elections have been allegedly tweaked with, disinformation's out there everywhere. So yeah, you can use it to trick people. Destabilizing. Kazushi in judo. I was a judo instructor for 11 years, 200 students. The biggest part of that is you set somebody up to fall over. You don't just push them over. If you do it right, it's effortless. And you protect them from falling too. But that's another thing. Destabilizing. It's called Kazushi. Putin, by the way, is a second-degree black belt in judo. Look at the facial expressions there. What's going on in their minds? Disinformation. No, Facebook. Cybersecurity, a little bit involved with this. I know U.S. Ambassador introduced me to these people. I hosted a cybersecurity symposium, did some things down at the Pentagon, follow-up after that. It's not my field of expertise, but I know a little bit about it, and I know people in it. Then this flying, oobless, driverless death. What could possibly go wrong? I'm being sarcastic there. Sensor fusion, integrating things together, integrating of processes, symbolic and AI mixed together. I mean, that's where we're going now. That's where we're at, actually. And then you can watch this this IBM Watson video. It's actually a little old now, but well, this starts with IBM Watson. I former IBM researcher. I didn't work on Watson. I was there in the mid '90s. Watson didn't exist, although I did develop some of the hardware that Watson runs on. But anyway, this is details on IBM Watson, and you can look at that, and I'm not going to go over that now. This is an overview lecture. and how Watson works, and started playing just as a game playing application specific use of AI and hardware and software. And then what they learned as they were doing that, IBM learned, and how that particular machine works, and the training, the tuning of it. And you can see, based on using previous data from other champions of Jeopardy, and it learns, teaching itself, more and more confidence in itself. It's a probabilistic guess based on certain things. It has neural networks in there too, and Symbolic-AI kind of things. And then problems. I read a number of books about this, and then you can look at how I've summarized those. And so, where are we going with this? Take a look at that. More on Watson. More on Watson. More on Watson. And even more on Watson. Still going. So, this, come back, take a look at it. This is several lectures to cover this right. And much reading. Again, I forget how many different books I read about this, and I was inside IBM, and I've been working on machine intelligence for 30 years. This is a very good, I guess it's getting a little dated now, it's 4 years old, but this is a very good demonstration of Watson, facilitated through this little robot. And in closing this talk, 2021 IBM Computational Biology, which covers systems biology, bioinformatics, pattern discovery, biomolecular modeling, genomics, human genome, evolutionary biology, medical imaging, neuroscience. So this is some of the applications within IBM, including Watson's use. Old school quality's lost? None, as long as humans stay in the loop with the AI. And just for fun in closing, this is my avatar when I was hosting servers, world servers in Minecraft.